So here in this problem, we're given that ABC represents the three vertices of a triangle. We need to show that each of the three cases are true. So let's begin. Now we know that if we have a triangle, any triangle, with the vertices represented by A, B, and C, then the sum of the angles, that means A plus B plus C, that always adds up to 180 degrees. Now what we can do, we can keep A plus B on the left hand side and transpose C to the right hand side to get 180 minus C. Now we're going to take the cosine on both sides. So we're cosine of A plus B, so that will be equals to cosine of 180 degrees minus C. Now let's try to rewrite 180 degrees. So we can rewrite it as cosine of 2 times 90 degrees minus C. On the left hand side, we have cosine of A plus B. Now the reason why we wrote in this particular fashion 2 times 90, then now we have an even number 2 which is multiplied to 90. So whenever we have an even multiple of 90 degree, then a cosine function that's going to stay as cosine, but the new angle is now only going to be C. We also have to confirm the sign of this particular new value cosine of C that we have obtained. For that we are going to go to a quadrant system. Now 2 times 90 degree means we are in the second quadrant, because the first quadrant corresponds to 1 times 90 degree, then the second quadrant is 2 times 90 degree. But then again, we're also subtracting C from it. Now C is an acute angle lying between 0 and 90 degree, so we're going to still lie in the second quadrant. Now in the second quadrant, only the sine and the cosecant function are positive, everything else is negative, so we'll have to take negative value here. It's going to be negative cosine C. Now if we rewrite this equation, rewriting this, then we already have cosine of A plus B on the left hand side, so we're going to transpose cosine C to the left hand side to get plus cosine of C equals to 0. This proves the first part. So let's go to the second one. For the same triangle, we can still say that A plus B plus C, that's equals to 180 degrees. We can rewrite it to get A plus B equals to 180 degrees minus C. Now we're going to divide both sides with 2. So we have A plus B over 2, which will be equals to 180 degrees divided by 2, that's 90 degree. So 90 degree minus C over 2. Now let's take the cosine on both sides. So we have cosine of A plus B divided by 2, that's equals to cosine of 90 degree minus C over 2. We're going to label this as equation number 1. Now cosine of A plus B over 2, which will be equals to, here we have 90 degree minus C over 2, so it can be also represented as 1 times 90 degree, and we have here is an odd multiple of 90 degree because 1 is an odd number. Since there is an odd multiple, since we have an odd multiple of 90 degree, so cosine is going to transform to sine, and the new angle will be C over 2. And we'll also have to confirm in which quadrant it lies. So 1 times 90 means we are in the first quadrant, and subtracting C over 2 from it is still not going to affect it because C is already an angle, acute angle lying between 0 and 90 degrees. So C over 2 is going to also lie, it's also going to be an acute angle. So we're going to lie in the first quadrant where all two functions are positive. So we get cosine of A plus B over 2 equals to sine C. Next, what we're going to do, we're going to take equation number 1. So following from equation number 1, let's take, instead of cosine, we're going to this time take the sine value. So we're going to take sine of A plus B over 2 equals to, we're going to taking the sine on both sides. So we have sine 90 degree minus C over 2 on the right hand side. So let's keep the left hand side untouched. So we have sine of A plus B over 2. But on the right hand side, what we have an odd multiple of 90 degrees. So the sine will get transform to cosine, we get cosine of C over 2. So this is still going to lie in the first quadrant where everything is positive. So the reason why we've done this, we're going to label this as equation number 2 and this one is equation number 3. Let's divide equation number 3 with equation number 2. So we have sine A plus B over 2 divided by cosine of A plus B over 2. So that's equals to cosine of C over 2 divided by sine of C over 2. Now this ratio, sine over cosine on the left hand side, that corresponds to the tangent function. So this can be also simplified to get tangent of A plus B over 2. which will be equals to, now we have the ratio cosine over sine on the right hand side, and that is the ratio corresponding to the cotangent function. We're going to get cotangent of c over 2. So this has proved the third part as well. So we've successfully proved the second as well as the third part.